तो हेलो गाइस, गुड इवनिंग, वेलकम बैक टू मार्गदर्शन बाय IITs। तो गाइस, आप सभी लोग हमारे इस सेशन में प्रेजेंट है। तो गाइस, आज हमारे साथ में विपिन कुमार, ही इज फ्रॉम मैकेनिकल इंजीनियरिंग एंड ही इज गोइंग टू फेस हिज HRRL इंटरव्यू सून। सो विपिन, टेल मी योर फेवरेट सब्जेक्ट्स और किस सब्जेक्ट के साथ हम मूव करें, पहले आप बताओ।
We
First,
can move from.
first tell us about yourself, and at the end, mention the subjects as well.
Okay. Thank you, sir, for asking for introduce myself. I'm Bipin Kumar. I belong to Jharkhand. I've done my undergraduate in mechanical engineering from Jadavpur University in 2021, and after that, I'm working TCS after graduating from my college. Apart from doing my curriculum work in my college, I've also worked as a uh, chassis design head in my motorsports club of our college, and I've done my industrial training from DVC Koderma Thermal Power Station, and my hobbies are basically cooking, traveling, and uh, playing badminton. And my favorite subject are mainly strength of materials.
Strength of material and which subject? Only one subject?
Yeah. Strength of materials and fluid.
Fluid. So sir, go on asking the questions on this song, please.
Yeah, sure. So, in strength of material, we have UTM, right? What does an UTM does? I mean, what's its purpose? What's the application of UTM?
UTM basically a machine which is used for the testing of the material by which helps us to draw the stress diagram, and where we measure its the material's yield point, ultimate tensile strength.
Correct. And what diagram does the UTM provides us?
Uh, it's a load versus displacement diagram.
Correct. So, a better word will be a load versus deformation diagram. Correct. And how do I
Yeah.
get a stress strain curve from that?
Uh, we actually, if we get the load, then if we are generally using engineering stress, so by dividing it by area first stress, and for the displacement by dividing it by original length, we can measure the points and we can draw the graph for that.
Correct. So you just mentioned engineering stress, right?
Right.
What's the another type of stress?
Another type of stress is true stress.
Correct. And what's the formula for both of those?
Uh, for the true stress, it is load given on the material by actual area, actual cross section area. It's a true stress, and for the engineering stress, it is a means original cross section area. That was the means at the initial stage.
Correct. And why do we use engineering stress like everywhere?
Uh, okay. So actually, it is easy for us to. It is very difficult to measure true stress at every point. So we generally use the engineering stress, and for the
Uh,
true
you are
stress,
you are right, but that's not a very particular answer. You're right.
uh, secondly, I think. Uh, so I think I don't know much about that.
Okay, fine. After that, as you can imagine, the real stress shows us the true nature of what the stress in a material is. Correct? because it is taking into the picture the actual area, not the initial one.
Yes.
But we still use
Correct.
the engineering stress. So
Yes.
don't you think the calculation, what we are performing, it could, it could be little risky in nature?
Means risky nature within, sir, you are asking?
I mean, when we design something and it could fail. So what I'm saying is,
Yes.
when we design something and because of we are using an incorrect stress here, which is engineering stress. I'm not saying it's incorrect, but it's little, off what the true value is. So could our design get a little bit riskier because of this approach?
Okay. Mm. If we say the engineering stress, according to that, we also have measured the limits of the material. So if we say that generally we see that the real stress, right? Real stress is always more than the engineering stress. So in that case, we can see that if we limit the material, limit the force with the engineering stress, then the material will not fail. We can assure that it will not cross the limit of uh, it will not cross the true stress.
Correct.
We can
And
say that.
you are right. But there one more point you can easily add. There is a factor that we consider while designing almost everything.
Mostly factor of safety.
Correct, correct. So essentially, when we have some factor of safety, the
Yes.
difference between the engineering stress and true stress, it doesn't matter now that much. Because the factor of safety essentially makes sure that whatever be the failure criteria, it will be much higher than what stress we are taking.
Yes.
That is right. So, when we increase the temperature in a material, what
Yes.
happens to its yield point? Or leave yield point, what happens to its Young's modulus?
Okay. Um,
What is Young's
Sorry,
modulus?
I'm not able to recall that. I think I'm
What is Young's
getting, but I'm
modulus?
not getting the correctly. Young's modulus is basically the mostly we say the ratio of the stress and strain, but it is basically the also the property of the material.
Correct.
Young's
And
modulus.
essentially it shows us like how easily the material the stretchability of the material is. Like
Yes.
how much force we will need to elongate it by, let's say, a certain level.
Yes, sir.
Correct. Now what if I heat up the material? Will I be able to stretch it more easily, or it will be harder for me to do?
No, it will be easily get stressed
Correct. And why is that?
because the we can say the bonds so that the material has it get reduced. Uh, if we consider the metal, it definitely get reduced between their covalent bonds or the electronic bonds.
Correct. That is right. And where do we exactly use this phenomena? We have increased the fluidity of the metal here.
Mostly we use it for in the case of annealing, normalizing in the steel industry. We use that to
Annealing, normalizing are, different processes actually.
it
I
means
mean,
we
we are
do
doing
the
that to
heating
either.
so that the ductility will increase.
Correct, correct, correct. I mean, what I was expecting is forming. In forming, we increase the temperature, and then we
Yeah.
apply a load. We deform the material.
Means the hot forming, you can say that.
Correct, correct. Yes, we increase its temperature. That is right. Yeah, Jay sir.
Yes. Basically, describe the Mohr circle or draw the Mohr circle.
So Mohr circle is basically Mohr circle is where we use a circle where the axis is one is sig- uh, you can say that the normal stress and second is the shear stress. Y axis we take the shear stress, and axis is we take the normal stress. And where there's the extreme points on the where the circle cross the axis, it has the maximum stress, maximum normal stress, or minimum.
Correct.
No issues. So tell me, what are the applications of Moore circle?
Moore circle we can use basically if we mostly sorry sir that I don't know what is the use of basically in the physically, but normally we use it in the numerical way.
Yeah, you are right. We use it in numerical way. That is correct. But when do we use it? Can you describe something?
When we don't know the real scenario, that how much uh, we can say that the stress that the sigma x or sigma y or tau xy we don't know. Normally we know the only the maximum stress on the material that we know. Then we can easily find out the tau, and we can draw the circle and find out the every stress at every angle of that area.
Correct. That is true. Now, you know, when we design something, essentially what we need is what is the maximum stress that is coming over it. So in that approach, we use Moore circle to know what is the maximum tensile stress, what is the maximum shear stress that is occurring in that particular component. So that's how we go with it. Yeah, I think Jay sir.
Yes, एक क्वेश्चन और पूछ लेते हैं, है ना? ठीक है. बेसिकली आप स्ट्रेस स्ट्रेन कर्व एक बार बना दो, ओके, वो बना के दिखाओ, और एंड पॉइंट एंड अल्टीमेट टेंसाइल स्ट्रेंथ का सिग्निफिकेंस बताओ मुझे.
So should I make the stress curve of the mild steel or normal case?
Normal case. Take a very general case.
General level.
Yeah.
You can see this.
Yes, correct. Significance बताओ मुझे. Yield point and
yield stress is basically the stress points where the material yielding starts. Means the if we increase yield stress points are the point where the material yielding starts. Means that if it stretch out the material beyond the yield stress, the material will not get its original formation. And in the yield, in the sense, so what's happening actually? It is cross the limit or something else?
No.
कोई बात नहीं, आपका इंटरनेट इश्यू है, मोबाइल से कनेक्ट कर लेते हैं आप, कोई दिक्कत नहीं थी, मोबाइल से भी कनेक्ट कर ली होती तो.
नहीं थोड़ा सा एक्चुअली वीडियो रिकॉर्डिंग वीडियोस हो, मतलब पता चलता है फेस रिएक्शंस क्या एक्चुअली. That's right.
Correct. That's very good thing to have.
So Basically, the yield stress is the point where when the material crosses the yield stress, we can see that it never get back its original shape, and when the at the ultimate tensile strength, it is the maximum stress that a material can possess, and after that it leads to fracture, and that's it.
So beyond yield point, I can say that the plasticity range is starting, right?
Beyond the yield point, we can say that the plasticity will start.
Yes. So it does not regain its original shape and size, original shape and path. Okay.
Yes, original form is not.
Sure. So अच्छा था आपका इंटरव्यू, थोड़ा सा आपको ब्रशअप करने की जरूरत है ना। अब आप थोड़ा सा मेरे ख्याल से नेटवर्क से अच्छे से नेटवर्क में आइए, तो फिर हम लोग आगे कंटिन्यू करते हैं फ्लूइड मैकेनिक्स वगैरह के इंटरव्यू के साथ, है ना। मैं आपसे कहना चाहूंगा विपिन, थोड़ा सा आपको ब्रशअप करने का जरूरत है। ब्रशअप करोगे तो और अच्छे से क्लियर हो पाएगी चीजें, है ना सुबोध सर।
Yes, also थोड़ा तुम्हें confidence चाहिए. I mean, clearly it is visible. You have the knowledge, you have what it takes, but थोड़ा presentation और I would say थोड़ा experience चाहिए तुम्हें. You know, like
इंट्रोडक्शन बहुत अच्छा था, इंट्रोडक्शन
yes.
बहुत अच्छा था। ओके,
And
उसमें कोई प्रॉब्लम नहीं।
correct. Just be ready to answer the question कि why you will leave TCS to join IITians or something like that. Okay. If you are mentioning that
So
in your
mostly yes, because it is needed, because if I can't deny that I'm not working in TCS.
That's okay. You know that's your choice, but be ready to answer with a good. Be ready to give a good answer to that question, because I'm pretty certain it is going to be asked.
Yeah, it
Okay.
is going to be asked. I know
TCS is
that
a big
it
company.
will
We
be
might
asked.
die to go in there, so be ready for it. Yeah. About your interview, yeah, I think little bit you need confidence, and I believe that would come with multiple interviews once you go and give multiple sets of interviews. So yeah, I'll say that.
श्योर। तो मैं गाइस, आप लोग ऐसे इंटरव्यू के साथ में हमारे साथ अभियान बैच में कनेक्ट कर सकते हैं, जहाँ पे हम लोग आप लोगों के ऐसी क्लास बढ़िया से बढ़िया इंटरव्यू ले रहे हैं हमारे अभियान बैच में। तो गाइस आप लोग HRRL, IOCL, MRPL, ONGC, गेल कोई हमारे अभियान बैच में एनरोल कर सकते हैं फ्रॉम डिस्क्रिप्शन लिंक, या फिर आप लोग हमारे व्हाट्सएप ग्रुप में कनेक्ट भी कर सकते हैं। थैंक यू, हैव अ नाइस डे।